Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have learned that how to switch on and switch off electrical devices using relays. In previous session, we have interfaced a relay with microcontroller and we have written a program to switch on and switch off an electric lamp with the help of relay. In relay control, we can switch on and switch off any device connected with the relay, and we can control only two states, that is 100% power to the device and 0% in off condition. But in some electrical control systems, it is required to control the voltages across the load, that is to control the voltage across the lamp, across the heater, control the speed of the motor using varying voltages, control the RPM of a fan, to control the AC voltages for different AC loads. We use a technique called firing angle control, and in this session we learn that what is the difference between relay control and firing angle control. In firing angle control, we use a solid state device belongs to thyristor family. Here we can see we are using a triac. Triac is a solid state switch to switch on and switch off the AC voltages for loads. To trigger the gate of the power device, we are using an optically isolated triac. Here we can see we are using MOC3022. MOC3022 is an optically isolated triac, and we are using this device to control the gate of the power triac. And here we are using BTA06-600 triac to control the AC voltages across this lamp connected with 220 volt. In this circuit, we are controlling the voltages of the lamp with the help of this triac. Here we can see with the help of this graph that we can increase or decrease the voltages with respect to time across the load. Before understanding the firing angle control system, it is necessary to understand the basic concepts of the AC voltages. There are two standards of utility power supply that we are using in our homes, in our offices, in our labs and in factories. One standard is UK standard, and in UK standards the voltage between phase and neutrals are 220 volt RMS and the frequency is 50 Hz. But in USA standards, the phase to neutral voltages are 110 volt AC and the frequency is 60 Hz. Here we can find the waveform of the AC voltages. It is a sine wave. The waveform of the utility power supply is sine wave, and here we can understand from the geometry of a generator that how it generates a sine wave. Here we can see the relation between the generated voltages and the angle of the rotor of a generator. At 0 degree of the rotor angle, the voltages are 0. At 90 degree, the voltages are at maximum positive peak. At 180 degree, the voltages are again 0. And at 270 degree, the voltages are at negative peak. And again at 360 degree, voltages are 0. We can find the voltages at any instant for this wave shape, that is I, with the help of sine formula. If we know the maximum peak of this waveform, if the RMS voltages of a utility power supply is 220 volt, then we can calculate its peak with the help of this formula. Here we can see the relation between RMS and peak voltages. If we divide the peak with under root 2, which is equals to 1.414, we'll get the RMS voltages. And if we know the RMS voltages, we can calculate the peak with the help of this formula. That is 220 volt multiplied by 1.414 equals to 311.08. Similarly, in case of 110 volt RMS, the peak voltages will be 155.4. In UK standard, the frequency of utility power supply is 50 Hz, and in USA standard, the frequency is 60 Hz. For the frequency of 50 Hz, the maximum time for a cycle will be 20 milliseconds, and for the frequency of 60 Hz, the maximum time for a cycle will be 16.66 milliseconds. We design our firing angle control system on the basis of UK standard, that is 220 volt RMS and 50 Hz frequency. Here we can see for 50 Hz sine wave, the time for half cycle is 10 milliseconds, and the peak voltages are 311.08 volt for 220 volt RMS system. If we'll apply the AC power to a load using a triac, we can control the power as per firing angle. If we'll switch on the triac near to 180 degree, then we'll have the minimum power, and if we'll trigger the triac at 0 degree, we'll have maximum voltages. So we can control the firing angle of the triac from 0 degree to 180 degree, and we can control the power to the connected load from minimum to maximum. To synchronize the firing of the solid state device, it is required to know the zero crossing of the AC voltages. We are using a step-down transformer to develop different power supplies for our prototype. Here we can see a 12012 volt RMS transformer from 220 volt, and here we have applied a 12 volt AC at one end of the non-inverting input of operational amplifier. We are using this operational amplifier, that is LM358, as a comparator. Inverting input of this operational amplifier is connected with ground, and non-inverting input is connected with the AC voltages with the help of 10K. These two diodes are used to clip the voltages at pin number 5 of the comparator within the range of plus 0.7 to minus 0.7 as the forward drop of these diodes. If the voltages at non-inverting input will be greater than inverting input, then the output of this operational amplifier will go to plus 10 volt. But if the voltages at non-inverting input will be less than inverting input, the output of this comparator will go to minus 10 volt. And here we have a general purpose transistor, that is C828, to convert these voltages between 0 and 5 volt. And we have applied a square wave of 50 Hz at the input of microcontroller. Here we can find we have applied the wave shape, that is zero crossing, at port RE0. To protect the base of the transistor from negative voltages, we have connected a diode between base and the ground. With the help of this 50 Hz square wave, we will control the fire angle of the trike using microcontroller. We will use the rising and falling edge of this wave shape to synchronize the microcontroller with 50 Hz power supply. Here we can find the connection of the load, that is the lamp of 200 watt with 220 volt AC power supply. And here we can see the arrangement of trike and optically isolated trike, that is MOC3022. Here we can see we are using a BTA06-600 trike to control the voltages across this lamp. And we are controlling the switching of the optically isolated trike with the signal, that is FAC, coming from the microcontroller. Here we can see port RE0 is connected with FAC and will generate a trigger signal for this trike from microcontroller. Here we can see the fire angle control wave shape across the lamp. We can control the fire angle from 180 degree to 0 degree to control the power across this lamp. Here we can find the parameters of the trike that we are using in our prototype. There are two types of packages, that is BTA06 and BTB06. BTA06 is insulated trike. Here we can see this device can handle up to 600 volt and can handle up to 6 ampere of current. Here we can see the schematic symbol of the trike, A2, A1 and gate, and here we can see the pin configuration of the actual device. The middle pin is A2, the left pin is A1 and the right pin is ground. Here we can see this pin is A2. Here we have A1 and this control pin is gate. Here we can find the optically isolated trike, that is MOC3022. We'll use this device to trigger the trike with the help of microcontroller. Now we'll discuss the technique that how we'll generate a fire angle control with the help of microcontroller. Here we can see the wave shape of zero crossing signal coming at the input of microcontroller, that is RE0. And we know that the time for half cycle is 10 millisecond and the total time for one cycle is 20 millisecond. So we have a wave shape which is 10 millisecond off and 10 millisecond on. In our program, we'll call an interrupt service routine at the frequency of 10 kHz and we'll use an 8-bit register and we'll call this register as ramp register. We'll increment this register in interrupt service routine. So in 10 millisecond with the frequency of 10 kHz, we can count maximum from 0 to 100. We'll increment the ramp register in interrupt service routine if the status of the input will remain same, but at each zero crossing, we'll reset the counter and we'll start counting again if the status of the input will remain same. In this way, we'll have a ramp which will go from 0 to 100 and this ramp will be synchronized with the 50 Hz power supply that we are applying at the load. We'll use another register as fire angle control register. We'll change the value of this fire angle control register from 0 to 100 and we'll compare this register, that is FAC register, with ramp register. Here we can see if we'll assign the value, that is 50, to the register, that is FAC register, and if we'll compare it with the ramp register, we can switch on the trike if the value of the ramp will be greater than fire angle control register. In this way, we can change the value of FAC register from 0 to 100 to switch on the trike between 0 degree and 180 degree. If we'll trigger the trike near to 0, we'll have the maximum power, and if we'll trigger the trike near 100 value, we'll have the minimum power to the load. And here we can see we are generating the fire angle control signal from port RE1 of the microcontroller. As we have discussed in our previous session that how to calculate the value of timer 0 register to get a desired interrupt frequency. Here we have the formula to get the register value. The desired time for interrupt frequency is 0.1 millisecond, that is 10 kHz. The value of crystal oscillator is 10 MHz in our case. We'll assign the prescaler rate, that is 8. After placing all the values to the above formula, we have calculated the value of timer 0 register, which is equals to 225. Here we can see the crystal oscillator frequency is 10 MHz and we are getting 2.5 MHz after division of oscillator frequency by 4. Here we have assigned the value of prescaler rate, that is 8, by selecting the bit, that is PS0, PS1 and PS2. And here we can find the configuration of the bits to get the prescaler rate, that is 1:8. So if we'll divide 2.5 MHz by 8, we'll get the frequency that is 312.5 kHz. And if we'll place the value that is 225 to the timer 0 register, it will take 31 steps to get the value of 255. And then timer 0 interrupt flag will be set and the program will go to the interrupt service routine. And here we can check if we'll divide the frequency that is 312.5 kHz by 31, we'll have a frequency of 10 kHz and it will give us the time of 0.1 millisecond. So we will assign this value to the option register, which is equals to 02. We'll also set these bits in our program, that is global interrupt enable, peripheral interrupt enable, timer 0 interrupt enable. And if all these bits will be set and if timer interrupt 0 flag will come, then program will jump into the interrupt service routine. Now first we'll develop the hardware of firing angle control circuit and then we'll write a program in micro C.